Good evening, my YouTube viewers. It's Crystal here. I just want to do another code review for you. And on this code review, I'm doing a convolutional neural network with the MNIST dataset. And basically, what we'll do is we'll just try to find out what a CNN is. And you can see I worked on it really hard. I did the neural network on Google Colab, and I decided to do it on Kaggle. And it worked on Google Colab, but it didn't work on Kaggle, and so I had to work really hard to actually get it to work. And let's just see what. Let's look at this. It says, what is a CNN? So, see what it says about what a CNN is. A convolutional neural network, or CNN or ConvNet, is a network architecture for deep learning that learns directly from data. CNNs are particularly useful for finding patterns in images to recognize objects, classes, and categories. They can be quite effective for classifying audio, time series, and signal data. And it talks about how CNNs work. It's only a paragraph, so I'll read that. A CNN can have tens or hundreds of layers that each learn to detect different features of an image. Filters are applied to each training image at different resolutions, and the output of each convolved image is used as the input to the next layer. The filters can start as very simple features such as brightness and edges, and increasing complexity to features that uniquely define the object. Okay, so that's telling you briefly what a CNN is. So if you didn't know what it was, you know what it is now. And so I had entered this Kaggle competition for the CNN for digit recognizer, and I decided to use a CNN, and I had a 98.9% accuracy. So that's almost 99% accuracy. And I did it on the digit recognizer competition with the MNIST dataset. So MNIST, Modified National Institute of Standards and Technology, is the de facto Hello World dataset of computer vision. Since its release in 1999, this classic dataset of handwritten images has served as the basis for benchmarking classification algorithms. As new machine learning techniques emerge, MNIST remains a reliable resource for researchers and learners alike. In this competition, your goal is to correctly identify digits from a dataset of tens of thousands of handwritten images. We have curated a set of tutorial-style kernels which cover everything from regression to neural networks. We encourage you to experiment with different algorithms to learn firsthand what works well and how techniques compare. So that's your problem statement. So I wrote the program in a Jupyter notebook in Kaggle, and it's stored in the repository of MNIST. And I will give you a link to the Jupyter notebook so you can look at it if you want to and copy it and play with it. So after I created the Jupyter notebook or created the program, what you have to do is you have to import the libraries. So I imported NumPy as NP, which creates NumPy arrays and performs numeric computations. I imported Pandas as PD, which does the data processing and creates data frames in series. I imported Tensorflow, which creates the neural networks. I imported matplotlib.pyplot as PLT, which is your visualization, and I imported Seaborn, which is also visualization. I also imported OS, which goes into the operating system and retrieves the files that are going to be used, and I imported sklearn, which performs the machine learning operations. So after I have imported the libraries, then what you need to do is we need to load and read the data set. So I use the OS library to go into the operating system and get the train test and sample submission. I use pandas to actually read these data sets into the system, and so I labeled the data frames because they converted them to data frames, labeled them train test and submit. So you can see train, which the label is the 0, and all the pixels are everything from 1 to 785. And so you can see that. And each row represents a digit. And test is exactly the same, except for the fact that it doesn't have a label. So test is 0 to 784. Let's just see something. Yeah, so, and then submit is image ID and label. So we check train info, which it's got 42,000 entries from 0 to 41,999, and it's a label to pixel. And then test has 28,000 entries, 0 to 27999. And then what we're going to do is we're going to check for null values, and we don't have any null values or test or train. So that's good. And now what we're going to do is we're going to check to see the incidence of each number. So you can see 1 looks like it's got the highest incident, and 7 has got quite a few numbers as well. So it doesn't have an equal representation. So what I could have done, which probably is what I should have done, is I could have said like label.value counts, and that will have told you how many times each digit appeared, which I didn't do that, but I should have done it, and I'm not going to do it again because it took me such a long time to get this correct that I'm just going to leave it as it is. So image ID equals test.index plus 1. So that's one thing that you can do. Y equals train.ilog, all of the rows and the column 0. And X is train.ilog, all of the rows and column 1 to the end. And then X test is test. So you can see Y. You can see what each number is represented by each row, and you can see X as well. You can see X test. So X and X test have the same format. Now what we're going to do is we're going to normalize X and X test by dividing it by 255, and then we're going to check the shape. So X is 42,000 by 784 columns, and X test is 28,000 by 784 columns. Now we're going to reshape X and X test. So reshape X equals X.values.reshape, X shape 0, 28, 28, x equals reshape x, and it says print len x, print x shape, and then we're going to do exactly the same thing with test. So the length of x is 42,000, and the shape of x is 42,028.28. The length of x test is 28,000, and the shape of x test is 28,000 by 28 by 28. Now what we're going to do is we're going to visualize one of the rows of data, and basically what I wanted to do is I wanted to randomly select it, because in most programs they'll just say, look, print 0 or print this or print that, but I wanted a random selection. So we printed it off, and we randomly selected a number 3, and the random selection was 40525. So now we're going to use sklearn to split the training data set into training and validation sets. So xtrain, xval, ytrain, yval equals train test split. X, Y, test size equals 0.1, random state equals 42, and you probably could have shuffled it. The shuffle equals true, but I think the default is to shuffle it anyway. So like if we come over here, and look under train test split, we're in the sklearn library. So it says that shuffle equals true. So the default is shuffle equals true. So even though I didn't say shuffle equals true, that's the default. So if you don't want it shuffled, you'd have to say shuffle equals false. Now what we're going to do is we're going to expand our dimensions from Tensorflow keras.utils import to categorical. Num classes equals 10, input shape equals 28, 28, 1. Then xtrain equals np.expand dims xtrain -1. Xval equals np.expand dims xval -1. And then xtest equals np.expand dims xtest -1. And then we print out things, but we didn't need this Tensorflow keras.utils import to categorical. We didn't need that. Basically what happened was I was trying to get it to work, and in some of the code I saw the to categorical, but in the end I didn't use the to categorical, so we don't really need that. Not really. And then I printed it off. So xtrain shape is 37,800, 28, 28, 1, 37,800 train samples, 4,200 validation samples, and 28,000 test samples. Now what we're going to do is we're going to get into the CNN. So that's your convolution neural network. And in this particular program, the version of TensorFlow that we have is 2.3.1. So that's a pretty old version. And since it's a pretty old version, all of the new code isn't going to work on it. So that's just something that we have to live with. But I made the sequential layer. Model equals models.sequential, model.add layers conv2, 3233, activation equals ReLU, input shape equals 28, 28, 1, model.add layers max pooling 2D, 22, model.add layers conv2D, 6433, activation equals ReLU, model.add layers max pooling 2D, 22, model.add layers conv2D 6433, activation equals ReLU, model.add layers flatten, so it's going to flatten it, model.add layers dense 64, activation equals ReLU, model.add layers dense 10, and then you have your model summary, and then your model summary gives you a summary of the CNN. So now what we're going to do is with batch size is 128 and epochs equals 15. So model.compile optimizer equals add-on. Loss equals tf.keras losses. Sparse categorical cross entropy from logics equals true. Metrics equals accuracy. And then you say history equals model.fit xtrain ytrain. Batch size equals batch size. Epochs equals epochs. Validation data equals xval yval. So it ran 15 epochs, and you had an accuracy of 0.9886. And then what we do here is we print off the accuracy and we compare the accuracy to the val accuracy, the train vector accuracy to the val accuracy. We print the val accuracy, and that's 98.85%, so that's 99%. Then we check the score. Score equals model.evaluate xval, yval, verbose equals 0. So verbose equals 0 means it's not going to show you printing it off. And then print test loss, score 0. Print test accuracy, score 1. So test loss is 0.043. Test accuracy is 0.9885. Now we're going to predict on the validation set. And as you can see, I worked really hard, and I could go through and change a few things to make it look better, but I'm not sure that I will, because it takes a long time to run it up and it takes a long time to save it. But we predict on our validation set, so ypred equals np argmax model.predict xval axis equals -1, ypred equals ypred flatten. We print the shape, which is 4200, and then we print show what ypred is, and you can see what ypred is. We create a data frame so you can compare the actual values to the predicted values. And now we predict on the test set. So predictions equals np argmax model.predict xtest axis equals -1. Predictions equals predictions.flatten. Print prediction shape and predictions. So prediction shape is 28,000, and then you have your predictions as well. So we prepare our submission. Submission equals pd.dataframe. Image ID is submit image ID, and label is predictions. And then we have the submission. And now what we're going to do is we're going to take the submission, we're going to convert it to a CSV file, which is submission.csv, and then we're going to convert it again to a data frame, and we're going to read the data frame. So that's it. So I worked really hard on it. There were a few things that I could have done to clean it up, to make it more pleasing to the eye, but since I spent all day on it, and I'm going to make a confession here, because I was trying to cook dinner, and then I have to do this all on my own. I have to do this all by myself. I was trying to cook dinner, and I was busy working on this because I couldn't get it to work because the code was